As we can see, this Keithley is in attractive condition. Nice leatherette grained cabinet. Try and keep this thing focused. It's difficult. I'm using one hand to film and one hand to rotate the item. There is one flaw in this unit, and as you can see here in the very corner, somebody broke a little corner out at some time. It's in the back. It's basically unnoticeable, and unless you were looking for it, you probably wouldn't see it. We'll take a look at the bottom here. The bail, the stand, is in good shape. Here's the bottom. As you can see, it's attractive. You've got the summary of ranges and other information on the bottom here. We'll give you a look at the inside of it in a little while, but the calibration on this is relatively easy to do. There's a calibration plate under the lid that acts as a shield as well for the components underneath, but on the calibration plate it gives you an indication of all of the steps to go through for the calibration. I think there are something like 18 or so steps. Obviously I've given this the calibration here on the bench, and we're getting really very decent results. We'll also take a look at the manual for the performance verifications, just to show that indeed the unit is functioning well. So as you can see, we have 1.4 zeros for 1 volt input, and we see 1 and 5 zeros on the Hewlett-Packard 34401A. And according to the DC performance tests, to be within tolerance, this unit must measure 1 volt from 0.9995 to 1.0005. So if you're within a half a millivolt of 1 volt, you're within tolerance, and we are dead on. So beautiful. In 20 volt range, we're going to go for 10 volts. Okay, we're flashing between all 9s and 10. We are reading 10 on the Hewlett-Packard. And in the 20 volt range, if we are 5 millivolts off, plus or minus 5 millivolts, then we're within tolerance. We are basically dead on. Let's go to the 200 volt range. Got 10 volts. Good. Let's go to the 100 input. Alright, we are reading 99.999 on the Hewlett-Packard. We're reading all 9s on the Keithley, and then flashing to 100, which would be right, because if you threw another 9/10 on there, we would be 100 in this range. And we see that at 100 volts input, if we're within 50 millivolts either side, we are within tolerance, but we basically are, again, dead on. Alright. We're on the 1000 volt range, and we are going to put in as much as I dare. Let's see, we'll try 800 volts. Okay, we're getting 799.98 on the HP. and we are getting 800 0 to flashing 0.1. And as long as we're within a half a volt, we are within tolerance. And we are definitely within that half a volt, so looking good. Once again to the 1 volt range. So there we are. DC wise, completely within performance verification and actually dead on pretty much every scale. Take a look at the AC performance here in a moment. Okay, so now we're connected up to the Fluke 5200A. That's an AC source. We've got 1 volt at 1000 hertz coming in. And as you can see, we've got 1 volt AC on the Hewlett-Packard. And we're getting 1 volt AC to 4 decimal places on the Keithley. Not shabby at all. Let's go ahead and take a look. Oh, by the way, 1 volt, if you're anywhere between 0.9945 to 1.055, you're within spec. Oh, we are dead in the middle, so perfect. Okay, we went to the 20 volt range. We're reading 0.998 at the moment. Let's go ahead and kick ourselves up to 10 volts. Okay, and okay, we have 10 volts AC on the Hewlett-Packard. We got 10 volts AC on the 178. We go to the 200 volt range. .98. Oh, well, you know, I should have looked. Sorry. 10 point, on a 20 volt range, 10 volts in, between 9.955 to 10.045, and we were basically right in the middle. Now this is 9.98 volts on the 100 volts or 200 volt scale. We're going to go to 100 volts. Okay. And there's our 100 volts AC on the HP. We're reading 100.08. Now, on the 200 volt range, 100 volts in, you should read 99.55 to 100.45. We're reading 100.08. So basically right in the middle of it, well within tolerance. It's working good. Let's go to the 1000 volt range. 99.8 is where we start. Let us go to, well, you know what, on the Fluke 5200A, the highest we can go is about 111 volts, which is only 11 volts higher than it is now. So essentially, here we are, we have come up to a little bit to 100.0 on the 1000 volt range. And I can't really go any higher. Let's go ahead and do it. We'll take her up. There's 119. In fact, let's go 119.9. It's 120. Okay. So 119.9999, and we're getting 120 volts AC on the HP. 120 volts AC on the Keithley. So that's as good as I can do at checking all the ranges with the voltages available, and they're right on. Let's take a look at the ohms. Okay, we got the Keithley and the ohm scale. We're using this resistostat 2 box as our standard for resistance. This contains a series of 0.01% tolerance resistors. That's 0.01, not 1%, but 0.01. So anyway, I've tested this box many times. I've never been surprised or had it fail or anything. So I trust that it's good. Plus, my Hewlett-Packard has verified these readings as well. So we're in the 2000 ohms maximum scale on the Keithley, and we want to apply 1900 ohms. So here's 1000, 1900 ohms. Now, according to the resistance performance chart, on this range, if we're between 1.8989 to 1.9011, we're good. We're getting a reading of about 1.9001 or 2. So we are right smack dab in the middle of that, doing very well. Let's go to the 20,000 ohm scale. Our 1900 ohms is still showing. Now we want to read 19,000 on the resistostat, so that would be 19,000, and we are getting 18,997 ohms. All right. For the 20,000 ohm scale, 19,000 ohms input, we should expect to see 18.990 to 19.01. 18.996 or 7 is what we've been getting, so again, we are right in the middle there. So we are well within the tolerance of the unit. Let's go to the 200,000 ohm scale. Our 19,000 ohms still shows. We now want 190,000. There's 190,000 ohms. And we are getting 189.99 to 190,000. So we are right there, smack dab in the middle of it. Okay, 190,000 ohms on the 1 megohm scale. We would like to get 1.9 megohms, and we get 189.9.7. So 1899.7.8. Okay. On this scale with 1.9 megohms, we should expect to see 1899 to 1901. and 1899.8. So we're good. Let's go to the 20 megohm scale. We're beginning to get a little noisy here too at this high resistance. Let's see, we want one. I can give us 10 megohms. 10 megohms, we're getting a reading of 9.998 to 9.999. I saw it flash. We're, I guess, 9.998. At this scale, basically you're reading 5%. It says that if I am 20,000 ohms off of 19 megohms, that I'm good. So let's see, that would be 20,000 ohms divided by 19 megohms is about 10%. On the 20 megohm scale, you're expected to be within 10%. And right now, we're reading 9.999 megohms out of a 10 megohm choice. So we are about 1,000 ohms off of 10 megohms, which 0.01%. So we're doing very well. Well, as always, if I can, I have the extra leads available. I do. In this case, I'll provide a set of test leads, and I'll provide the Keithley 178 manual on CD. So there you go, one beautiful unit, performing excellently, calibrated. Calibration alone is worth over $150, so if you go to get one calibrated professionally with a certificate, like I did my Hewlett-Packard over here, we used as the comparison, you're getting a hell of a bargain here. 5 digits, well, 4.5 gives you 5 digits under the right circumstances, and that would about cover it. So, okay, thanks for listening, and we hope to see you again another time. Bye.